All right, in this video, we're going to tie a couple of calculus concepts together with curve sketching, which you did some of in pre-calculus. So suppose you were looking at this fourth degree polynomial. Last year in pre-calculus, you were able to determine zeros, y-intercepts, and behavior, all of that stuff, but you couldn't really figure out mins and maxes, nor could you figure out points of inflection, but we can now do that with calculus. So this would be your graph that we're going to try to come up with at the end. So the process is basically going to be the same as last year with the added bonus of increasing, decreasing, concave up or down, and any extrema and points of inflection. So let's say we have that same function and we're going to sketch the graph of that thing. We want to go through all of the different parts. So to find your x-intercepts, as you should recall, you set y equal to 0. And then here you might need to do some review on synthetic division. So it looks like 4 is repeated 0 3 times, and x is a 0 once. So you can remember things about multiplicity if you want to, but we're going to determine the behavior of the graph near those points using some sign analysis of derivatives. So those are our x-intercepts. Remember, to get your y-intercepts, you set x equal to 0. Kind of makes sense that if x equals 0 is an x-intercept, then it should also be a y-intercept, since that's where the axes meet. So now let's go ahead and find asymptotes. Well, since this is a polynomial, it does not have any vertical asymptotes. To find horizontal asymptotes, by definition, that is the limit as x goes to infinity, or the limit as as x goes to negative infinity. So if I take the limit as x goes to infinity, I get infinity. If I go to minus infinity, that limit comes out to be infinity as well. Kind of just reaffirms how the end behavior should be going up on both sides. If this was an odd degree polynomial, one of these limits would be positive infinity, the other would be negative, kind of that end behavior chart you might have memorized in Algebra 2 and pre-calculus. Next, let's find any extrema. So find derivative, set that derivative equal to 0. You might need to do some more review on synthetic division and factor by grouping. Looks like we get x equals 1 and x equals 4 are the two critical numbers. So those are the zeros of our derivative. If I do a sign analysis near each point, so to the left of 1, in between 1 and 4, and then to the right of 4, looks like at x equals 1, I'm going to have a relative minimum because I change from decrease to increase. No relative maximum because I don't change from increasing to decreasing. Speaking of, looks like I have decreasing from negative infinity to 1 and increasing from 1 to 4, 4 to infinity. Notice we don't include 4, and that's because at 4 we actually have a horizontal tangent, but we don't have a min or max there. Next, let's look at concavity. So take that derivative and then take its derivative using power rule. You get a quadratic, set to 0. Factor, looks like you get 2 potential points of inflection. So let's do that sign chart with f double prime. Looks like to the left of 2, you get concave up. In between 2 and 4, you have concave down. And then to the right of 4, you have concave up. So this tells us that we have 2 points of inflection because at 4 and 2, we have changes in concavity. So those y values, negative 16 and 0, those are going to give us the points on our graph where we have a point of inflection. Also notice the concavity I mentioned a second ago. That'll help us graph this thing. So if you were to take all of this into account, you're going to make this nice, neat graph like we saw at the beginning. The big difference now is we actually can figure out how far down we go all the way to that negative 27 when x equals 1. And all of this we could do without a calculator. So we can find points of inflection, we can find mins and maxes, all of that stuff. So just things to watch out for. Not every function behaves the same. Look for those vertical asymptotes with rational functions. Just kind of pay close attention to the different function types that you studied last year. And just, again, the added piece is first and second derivatives, how they tell us things about concavity, increasing, decreasing, extrema, and points of inflection. That should give you plenty of info for those questions on Schoology.